Hello, my name is Matthew Kerr and I'm from Glasgow. I did my undergraduate degree at the University of Glasgow, which was in mechanical engineering with aeronautics, and I graduated with a master's in 2016. So in the 4 years between then and joining the ERBE programme, I worked as a project manager and then a process engineer in a manufacturing company making aerospace components. So why the move to ERBE? Well, I was really motivated by the UK government's 2050 net zero emissions goal, and I wanted to get involved in addressing this great challenge. So I started looking for opportunities to join the energy industry, and I came across the ERBE programme. It looked like a lot of practical, real-world applicable work was being output from each of the research groups involved, and I wanted to join a community like that of people actively working to improve the built environment and reduce the harmful effects of climate change. As an engineer, I've always wanted to use my technical abilities and experience to solve problems for the wider benefit of society, and I could see from the ongoing research that ERBE considers people and their lived experiences just as much as the technical solutions, so it seemed like a great opportunity to get involved. So my research. Well, my working title is Assessing the Energy Flexibility Potential of UK Building Energy Systems, and it falls mostly under the ERBE theme of flexibility and resilience. There are two broad areas which my research will cover, which are demand-side response and energy flexibility in buildings. Essentially, it is all about balancing energy supply and demand between the grid and buildings. In the context of my research, demand-side response and energy flexibility in buildings have the following definitions. Demand-side response is when consumers alter their energy demand from the grid based on external conditions, such as to curb peak demand on the grid, or when local storage or renewable generation is available. Usually this is incentivized through costs such as peak and off-peak pricing. Energy flexibility in buildings is the ability of a building to participate in demand response effectively and maintain service for its occupants. This relies on the energy systems present in the building and also the fabric of the building itself. Now, let's get some context before we go into more detail about what I've been doing so far. This graphic is taken from the UK government's Powering Our Net Zero Future white paper, which was released last year, and I think it provides a really good overview of how the electricity system in this country is changing and what the vision is for the future system. So we're going to have a more decentralised system with generation and storage assets all over the place. Increased electrification is certain, with things like heat pumps and EVs being supported for widespread rollout. And consumers will take a more active role in the energy system with storage, peer-to-peer markets, and demand-side response. This creates a couple of potential issues and complexities. With more demand on the grid coupled with more generation from intermittent, difficult to predict renewable sources, we need to be careful that generation can still meet demand without resorting to burning fossil fuels. And this is where concepts like demand response and energy flexibility come into play. So far in my first year, I've completed the 10 coursework modules and I've just finished my pilot study. This was a purely modelling and simulation based piece of research, and I was looking at demand response and energy flexibility in homes equipped with either a variable or a non-variable output heat pump. And my question was basically, how can the heat pump best be used to provide demand side response whilst maintaining heating services to occupants? Essentially what I found was that the needs of the grid are often at odds with the needs of the home. But if the technology, in this case the heat pump, is operated in an optimal manner, you can yield benefits for both parties at the same time. For future work, my focus is on how we can implement demand-side response in practice. So to me, you have two sets of objectives, one for the energy grid, like reducing demand at peak times, and one for the building, like maintaining suitable and stable air temperatures. You then have various building energy technologies, which are the interface between the grid and the building, and the way in which this technology is operated will determine the level of energy flexibility which is achievable. So far, I've only used modelling, but I would like to move towards a case study to validate my work in a real-world situation. This would consider coordinated demand response from multiple buildings with a range of energy technologies in each. My experience with ERBE so far has been really enjoyable. The coursework is challenging, but it's really rewarding. My piece of advice for everybody would be start all the assignments as soon as you possibly can. You cover a lot of different domains like building physics, economics and policy, social theories, and how to plan research projects. And I think that wide scope of different topics was what made it really interesting for me, and I learned a lot. And everyone so far has been great to work with. So I'm interested and completely open to collaborating with others, so please feel free to reach out. The most challenging aspects for me are understanding the UK housing stock and building physics, and also incorporating social sciences into energy flexibility. So if anyone's interested in either of these domains, please do let me know. Beyond research specifics, if anyone wants to discuss anything about energy system flexibility or just the ERBE programme in general, I'd be more than happy to have a chat. My email is listed here if you want to get in touch. Thanks again, and I look forward to meeting you all soon.